fellow assassins, to another episode of the Dark Assassins podcast, the show that dives deep into not just technology, but the concepts, software, and procedures behind it all, and explains it so simply that even your grandma can understand it. As always, I'm your host, the Dark Assassin. Depending on what your career goals are as a software developer, there's probably a decent chance to potentially even a certainty that you will have to have some sort of basic knowledge as to how cloud computing works. Now, I believe we've touched a little bit here and there about different aspects of cloud computing in the past, but while you might not be tasked, like in a software development job, you might not specifically be tasked with creating the infrastructure, or potentially like designing how that infrastructure is going to work. Typically, that's usually reserved more for like a solutions architect type thing. Although that's not to say that as software developers, you do kind of create your own infrastructure in the process. But regardless, your code will almost certainly be running in some form of cloud resources. And if you take it at its most literal sense, being that the cloud, well, I guess in the one sense, the cloud doesn't exist. It's just someone else's computer. So if you take it at that very literal meaning, unless you are running your service or something on something you don't directly own, like you're not running it on infrastructure that you personally own, technically speaking, you could say you're running it in the cloud. Now, typically when people talk about running things in the cloud, they're talking about running things in AWS, Azure, Google Cloud, or one of the other, various cloud providers. So being able to understand how these cloud resources work and more specifically how they work together can basically take you from being an okay developer to kind of taking you to that next level. Because if you understand how the cloud platform itself works and how all the various services interact with one another, it makes designing and implementing your application a lot easier because you kind of have at least a general sense of how these things are going to interact with one another. And it's the same thing like if you're not using the cloud and you're using some, personally spun up stack, like you're using a SQL database or something with some other kind of, server front end or something, like in making, requests to that database, you kind of have to know how those two are going to interact in order to adequately design your program. And that's the same thing when you're dealing with cloud applications. It's just the different utilities and tools and whatnot that you're going to be doing might be slightly different. But let's be real here. There's a reason that the meme exists about individuals and or companies going bankrupt because they left their AWS EC2 instance running. Because cloud computing is not cheap, especially if you're just trying to learn how it all works. And this is where Homelabs come into play. Now, in a home lab, you can spin up very similar infrastructure to what you could find in any one of the major cloud offerings at a fraction of the price. Now, of course, if you don't have any infrastructure at your disposal, yeah, it might be cheaper to, do some cloud stuff for a couple months, unless you're, spinning up some EC2 instances and just kind of letting them run and you get hammered, then you might run into some issues. But if you already have infrastructure or you have like an old, device lying around, that could be a fantastic way to start spinning up some infrastructure in your house, in your home lab, and start to, gain some understanding and learn about these different technologies. Because while they're not, exactly the same as what you're going to be using in the cloud, the skills that you learn through, testing them out in your home lab will absolutely transfer to whatever cloud platform you ultimately end up using at wherever your day job happens to be. So we're going to kind of dive into that deeper into this episode. But before we do that, let's get into the trivia question for the week. So, this week's trivia question is, what was the name of the computer controlled radiation therapy machine produced by Atomic Energy of Canada Limited in 1982 that was involved in at least six accidents between 1985 and 1987, in which some patients were given massive overdoses of radiation due to concurrent programming errors, also known as race conditions? So, what was the name of the computer behind all of that? And that is your trivia question for the week. So, like I mentioned last week, the car trivia questions couldn't go on forever, and they finally stopped. So, if you were sick of them, I guess you're welcome. And if you were liking them, I am sorry. So you can't please anyone. But with that, let's get into this week's cybersecurity tip. Now, this week's cybersecurity tip is to be mindful when using third-party plugins. Now, it doesn't matter which application or platform you're using, it's always best to verify it before you install any plugin, whether that's your text editor, like you're using VS Code or VS Codium or Vim or any of the other text editors that allow plugins, or you're using a web browser or WordPress, perhaps. You always want to make sure you're verifying your plugins before you just go willy-nilly installing them, because there are plenty of people out there that would love for you to install their malicious plugins so they can do who knows what with your device. Now, threat actors are notorious for creating these malicious plugins in the hopes that people will install them. There's tons of them out there on like basically any web browser, like the Chrome web store. Pretty sure Firefox has some as well. Um, I'm not sure about. I'm sure there's some that probably exist for like the whole VS Code family of text editors. I'm sure, and WordPress is absolutely a massive victim of these malicious plugins. And once again, there are more instances of these malicious plugins on WordPress. Now, if you've listened to the podcast for long enough, I don't talk about WordPress a ton, but the times I have talked about it in the past have not been in a very positive light. So it's not really a big secret that I am not particularly a fan of WordPress. Now, don't get me wrong, WordPress has done a decent job, I guess I'll say, of making the creation of a personal website, or maybe even a website for a small business, very accessible to those individuals with either little to no programming knowledge, or they just don't really have like the time or energy to actually create their own website from scratch. So in that sense, it's done a, I guess, decent job of making the ability to have a website more accessible to people. But at the same time and time again, it has become such a harbinger of vulnerabilities. And this week is no different, because cybersecurity researchers this week have discovered multiple malware campaigns targeting WordPress, and Magneto, which I believe supposedly is an open source e-commerce platform. I've never used it, but one of these campaigns involves a malicious malware plugin called WP-anti-malware-bot.php that disguises itself as a security plugin. Now, basically, what the plugin kind of does is it provides threat actors with admin access and allows them to execute remote code. So, yeah, fantastic. That's exactly what you want. And so, how it does this is there are several variants that can spread malware and inject malicious JavaScript to serve ads. Another campaign out there, one of these newer WordPress malicious campaigns, uses fake fonts to display fake payment, basically a fake payment form. to essentially steal information. So I mean, it's no secret if you've gotten some kind of phishing email before. If you don't click on the links in phishing emails, of course, but um, they've gotten to the point where they are basically able to perfectly replicate the website that they're trying to scam you for. So the logins and everything looks very legitimate. So, and basically the whole point of those is for users to basically enter their credentials because they think they're logging in to the legitimate website, even though they're not. And really, all that's happening is they're just harvesting those credentials so then they can either sell them on the dark web or use them to try to hack people, whatever their, I guess, whatever their MO is. So that's, basically what one of these plugins also does. And that one was specifically targeting the e-commerce site with more JavaScript malware in there to basically designed to harvest, credit card details, login credentials, all that fun stuff. And also, another campaign that they've had is basically trying to observe and inject Google AdSense code into WordPress in order to deliver unwanted ads and generate revenue. Now, if you're using some sort of ad blocker, you're probably not even going to notice this if a website has it. Because it obviously blocks ads. But some of the compromised websites have also been found to serve deceptive CAPTCHA verifications. So those are, of course, the things where it's like, are you a robot? Select the pictures that are a bus or a crosswalk or a fire hydrant or something like that. But basically, what it does is it's also being used to trick users into downloading and executing malicious Node.js backdoors in order to grant them remote access and deploy remote access Trojans or rats. So very, very fun stuff coming out of WordPress. But maybe, just maybe, WordPress isn't the problem here. Now, I will be straight up with you. When I was first, looking into this story, I was like, good old WordPress, another vulnerability, here we go. And then after I was, finished reading through it, I was like, wait a second. Every single one of these things they mentioned had something to do with JavaScript being involved. So maybe, just maybe, the issue isn't WordPress, but rather JavaScript. So perhaps if we just remove JavaScript from the face of the earth, none of these vulnerabilities would happen. I mean, obviously, some of them still would. It's just like the implementation of how these vulnerabilities are run, basically using JavaScript as a means to an end, which in fairness, if you want to actually, dig into this, conspiracy theory, fake argument that I'm putting up, the easy rebut is, well, you could easily use any programming language as a front to deliver malware. And you are absolutely correct. But this is JavaScript, and I like making fun of JavaScript, so I'm going with it. So technically speaking, if JavaScript didn't exist, technically none of these vulnerabilities would exist because they all use JavaScript as a part of them, whether it's the delivery mechanism or what have you. So yeah. Now, obviously, if JavaScript didn't exist, some other programming language would easily fill the void, I am sure. But yeah. So if you're using WordPress, definitely be sure to use a significant amount of caution when you're installing third-party plugins, and also just in general make sure you're always up to date with any kind of updates that come out, because WordPress has, at least in the past, historically hasn't necessarily been the best for have not they're not necessarily known for being impenetrable when it comes to their security. There's been numerous vulnerabilities over the years. So if you are using WordPress, definitely make sure that you are up to date on everything, and definitely be very mindful of what plugins you install. But this also doesn't exclusively apply to WordPress. Like I mentioned at the top of the cybersecurity tip, this applies to any application that allows the support for third-party plugins, whether that's, like I mentioned, a web browser, a text editor, editor, or maybe some kind of like audio interface if you're a video editor, whatever your video editing platform of choice is, whether that's Adobe, Final Cut, iMovie, whatever, or your IDEs if you have third-party plugins for there. Just be very mindful of what plugins you're installing and make sure they're actually legitimate before you go installing them. And that is your cybersecurity tip for the week. Now, moving right along, let's get into what nerdy stuff have I been up to this week. So, last week I talked that I wanted to get into fixing some of the issues that SemGrep was complaining about, but this week I finally got around to doing that. And I also added another stage to my pipeline, this one being basically to ensure that the code is properly formatted, which was honestly pretty trivial to do. Since I already have a .clang format file in the repo, basically just to ensure all the code's formatted to the coding standard that I set out. And basically all it does is it does a dry run check of all the files to see if any changes are necessary, and if there are, basically just fail the pipeline right then and there, be like, hey, your code isn't formatted properly. And yeah, so it is cool to see another stage in the pipeline. So that is very cool to see. But getting on to the SemGrep stuff, I have to say, I am kind of annoyed because every single quote unquote error ended up being for a possible buffer overflow that was literally impossible in every single case that it flagged it for. And I touched on this a little bit when I first got SemGrep implemented into the pipeline. I noticed that at least one of the things it was complaining about was a case where it was like, oh, you're using sprintf, and that is susceptible to buffer overflows because it doesn't do bounds checking. Error. And yes, you're correct, but if you literally looked at the code preceding that call, you would easily see that a buffer overflow is impossible because all of the checks required to make sure the buffer is of proper size have already been done. This is include checking for nulls, making sure the buffer is allocated to the appropriate size +1 for the null terminator byte. Everything you need to do to adequately make sure your buffer is the correct size to take in the incoming data was done, but I guess the tool was not able to see that. Now, it wasn't just sprintf. There was probably at least like 3 or 4, I think, string strcpy instances as well. Again, the exact same issue. It was like, you're using strcpy, that's not safe, the possible buffer overflow. And I'm like, if you literally looked, the 4 or 5 lines preceding that strcpy, you would actually see that all the precautionary steps are being taken to ensure that no buffer overflow will actually happen. So yeah, if you can't tell, I'm kind of annoyed right now. Now, don't get me wrong. It's widely understood and widely known that the functions like strcpy, sprintf, strcat, and all those other functions in C that do absolutely no bounds checking whatsoever are unsafe, and it's even stated as such in like the man pages. It's basically saying, hey, you probably shouldn't use these functions. But I don't want to rant about this too much, because while I could absolutely rant about this for a significant amount of time, this actually got me so riled up that I started work on creating a new blog post. So yes, the blog is coming back, as well as a YouTube video basically diving into all this, and basically showing that yes, you can actually use these functions correctly and safely and not be susceptible to buffer overflows. But in the process, of course, I'm going to show why they get this reputation of being susceptible and why it's generally understood that you shouldn't use them. So we're going to get into some actual hacking and do some like legitimate buffer overflow exploitation, and get some uh, remote code execution isn't necessarily the correct word, I guess, but also technically yes. Basically, there's in the example that I have cooked up, there is a secret function that is never called, and basically we're going to use the buffer over exploit in order to run that function and get it to basically do what we want. Now, of course, with this buffer overflow, the one that I'm going to demo is a very basic buffer overflow exploit. You could obviously make this a lot more sophisticated, a lot more complex, doing things like setting up a shell, popping a shell. You could do that. There's other things you could set up, basically a remote listening port, so you can kind of remote access in to the device. There's a lot of stuff you could do. Install malware, basically whatever you want to. But for basically just the proof of concept point, I'm basically just keeping it very simple. So I think it's going to be pretty interesting going over and actually showing how these exploits actually happen, because we talk about buffer overflows and memory safety vulnerabilities quite frequently on the podcast, but actually having something to actually demo it working in practice, I think will be very cool. Especially if you've never seen it done before and you've only ever heard that it's technically a thing, but you've never actually seen it happen. And part of the reason for that is all of the protections that are baked in to not only the compilers, but also the operating systems themselves to try to make sure that these can't happen. So there's things like address space randomization. There's protections like canaries and stack execution protections. So there's a lot of stuff like natively baked in to try to prevent these super simple buffer overflows like I'm gonna demo. In order to basically make you basically have to have a lot more sophistication in your exploit. Not to say that if all those protections are in place, it's not possible, because it absolutely is. It's just a lot easier if those aren't in place, as you will see if you watch the video or read the blog post. Um, so definitely be sure to stay tuned for that. But I guess if we want to look on the bright side of things, because I've been very Debbie Downer about SemGrep and it complaining about stir copy. On the bright side of things, it is looking out for you in the sense that if you do forget to do the preliminary bounds checking like I was doing, it'll at least warn you and prevent you from just blindly calling stir copy or sprintf or whatever, and potentially protect you from a buffer overflow. Now, that's not to say if you use one of the quote unquote safer options like stir n copy, which is basically the same thing as stir copy, except you set a maximum length, you can absolutely 100% still have a buffer overflow if you use something like stir n copy. Just the catch is it's usually a little harder to do that, because you kind of have to make the cognitive choice that the length variable that you're passing in for like the maximum amount of data to copy is actually larger than the buffer you're copying it into. So you basically have to make a legitimate programming error rather than just like a naive like, oh, I just used stir copy and didn't think about it type of a thing. Like you actually cognizant wow, I cannot say that word. You have to actively know that you're putting in the wrong length for the buffer that you're copying into in order for a buffer overflow to happen. Now, it's probably a little easier to exploit on something like strncat, where you basically select the length for what you want to concatenate. And basically all strncat is if you've used a more modern programming language with strings, when you do like the whole plus equals thing to basically append to the back of the string, that's basically what strcat's doing, or strncat. So it's a lot easier for something like that to potentially buffer overflow yourself, because you're not necessarily keeping track potentially of how much you've already put into that buffer. So in that case, it is very plausible where you're like, oh, I'm just going to pass the length of what the actual buffer is. But little did you know, or maybe you forgot that the buffer is already filled to say like 90% capacity, and the data coming in is a lot larger than that, and you said go up to the length of the buffer so you could potentially overflow it that way. Um, so yeah, just some things to keep in mind. But it's I guess the TLDR here is the only reason that stir copy, sprnf, stircat, and all those other functions are dangerous. It's is because it's a skill issue. I guess is the TLDR. It's a skill issue, because if you're doing all of the adequate checks and precautions, um, it is impossible to have a buffer overflow in such a case. Now, of course, that's not to say that there's no work involved, because, like I said, there's a lot of precautionary steps you have to go and do ahead of time to make sure your buffer is of adequate size, allocating the memory, making sure the allocation actually succeeded, and then finally doing the copy. So it's not as simple and trivial as, in more modern languages where you can just set it equal to or do like a plus equals or something like that. Now, with that said, it everything is fixed, so the pipeline isn't complaining anymore. So the pipeline is actually able to complete without erroring out, which is nice. So with that out of the way, I think I can finally get back to doing some actual real development. Most of the programming, I guess programming in air quotes, I guess, because really hasn't been much as far as feature implementation or anything. It's been kind of like housekeeping type stuff. It'll be nice to actually get back and be able to actually, work on some real code. But I will say, having the pipeline fully succeeding again with 5 stages and having 5 green check marks inside of GitLab is quite nice to see. I do have to say. So that's going to do it for the nerdy things. So now to get back to what we started the podcast off with, which is the whole cloud computing thing. So, cloud providers, if you have been living under a rock for the past probably, I don't know, 15 years or so, maybe 20, depending on how techy you are. Cloud providers are essentially just companies that offer cloud computing services, which allow users to do everything from store data, manage things, process data over the internet. Basically, any kind of typical tasks that you would have offloaded to like a data center or something to do, you can essentially offload to the cloud. So the whole kind of selling point of the cloud is you don't have to house your own, basically procure your own data centers and buy all the servers to put in those data centers and manage everything. All that's done for you. Basically, all you have to do is spin up whatever applications you want and use the services that they have, and you don't have to worry really about any of the infrastructure pieces. Because back in the day, if you wanted to host like a web service or something, or some service on the internet, you basically had to have a server somewhere in a data center, basically running 24/7 in order to house that service. And because you wanted, as much uptime as possible, you would need redundancy, so you'd need servers in multiple locations. And then comes the challenge of, well, if you want to, have customers in, say, Europe, and you're in America, having servers over in Europe in order to have, closer access to them, and having content delivery networks in place in order to make sure that that when a customer is requesting your site, that you're giving them the site closest to them, type of a deal. So there's a lot of like logistic stuff that goes into hosting your own server infrastructure on that large of a scale. So kind of the point of the cloud was basically say, hey, you don't really have to worry about that anymore. You can just focus on, writing and building the applications, and we'll kind of take care of all the back end infrastructure pieces. Now, of course, depending on, what services you're using, you might still have to, manage things like virtual machines and whatnot. but that's a lot easier than, say, having to manage the physical servers that are running all across the world. Now, like I mentioned at the beginning of the episode, there's really three main players in the cloud computing game. There's Amazon Web Services, or AWS, there's Microsoft Azure, and then there's the Google Cloud Platform. And of course, there's a bunch of other smaller organizations as well, like there's Akamai, which formerly Linode, DigitalOcean, Hetzner, and there's others as well. Um, but basically, these cloud providers, they offer a varying range of services, including everything from, computing power like virtual machines, and what they call serverless functions, which is so funny because if you hear the name and you're like serverless, how does serverless actually work? Essentially, in a nutshell, is it's basically you basically just write functions and code that you don't have to worry about, what servers and whatever it's running on, and it'll scale up to meet whatever demands you need. Of course, you can set limits on it, but you don't have to worry about necessarily having virtual machines and having them potentially just sit there idling, doing nothing, and wasting resources. Is generally the premise. But there's also other things too. Things like storage. The big one in cloud computing is like S3 buckets is kind of like the hot thing. Databases, analytics, and a whole bunch of other things as well. So we've kind of touched on some of the importances of cloud computing, but the kind of the benefits that cloud computing offers, or what they claim they offer to businesses, is one, scalability. We kind of touched on this already. If you house all the infrastructure yourself, if you want to increase your capacity or scale larger than what you already have, you basically have to procure more hardware and potentially even more data centers. That takes time, that costs a lot of money to do that. Whereas if you're using the cloud, you can easily, spin up new virtual machines, or if you're using Lambda functions or whatever the cloud platform calls them, having that basically on-demand scaling capability is to meet demands, and not really you having to worry about it, is something that is potentially very nice. The flexibility as well, because there's a wide range of tools that cloud providers offer. Like I mentioned, the whole, serverless architecture. Most cloud providers offer some kind of serverless architecture. They offer containers, they offer virtual machines. There's a wide array of services that you can take advantage of depending on how you want to build and implement your app. You could do it all serverless, you could do it all through virtual machines, you could do it through containers. However you want to do it, the cloud provider basically gives you that option. And the other thing too, different types of database options, different types of storage backend options, different tiers of storage. So there's a lot of, obviously, flexibility there. Whereas if you were running and managing all the infrastructure yourself, you don't necessarily have all that flexibility potentially. Now, there are, some solutions that you could leverage and take advantage of. Like you could use, say, something like Proxmox, for instance. And Proxmox has native support for LXC containers, as well as virtual machines. So you kind of have those two in there. Of course, you could also just spin up a virtual machine to house Docker containers if you prefer that. That's personally what I do. But there's ways that you can kind of sort of emulate it, and that's kind of, what the point of I wanted to get at with this episode is. Even though you might not necessarily be using the cloud specifically, like maybe you're not using Azure specifically, but being able to do similar stuff to what you would do in Azure, like working and managing virtual machines or containers or what have you, that can then translate into that cloud experience. But the other thing, the kind of getting back to kind of the allure of cloud computing, is the cost effectiveness. Now, we joked at the beginning of the episode about the meme of, someone or a company going bankrupt because they left an EC2 instance running. Um, but in general, if you only want to, say, house like a single virtual machine or a single service, it's probably going to be cheaper to do it in the cloud rather than buying up, the hardware required and basically housing and managing the infrastructure yourself. Because but it really depends on what your scale is, because there's a tipping point. Where that tipping point is, that's very dependent on you and what your needs are. But especially if you don't have any infrastructure already and you want something that has that basically 99.59% uptime, you're probably not going to get that hosting it yourself at your house, because unless you have, like redundant ISPs and like redundancy measures in place, so if your power goes out you can keep your servers running essentially indefinitely, you're probably not going to have that massive uptime. Plus, you'd also have to have some sort of way to manage, failover if, a service fails, or, whenever you need to make updates to a server. How are you going to do that if you need to do reboots and whatnot? So, if you're working in the cloud, basically all of that logistical headaches and management stuff to ensure that uptime is basically handled for you, which is nice. The other thing too is if you do it in the cloud, you don't have to worry about your personal IP address being potentially exposed. Now, again, all this could be alleviated too is if you did some kind of co-location, which is essentially you put your own server in a data center somewhere. Um, but the thing about that is it's also depending on how much rack space you want and whatnot, that there's a significant cost to that as well. So there's a lot of, I guess I'll say, upfront cost and ongoing cost, with running your own infrastructure, which you kind of sort of don't need in the cloud. Now, again, it obviously depends on what resources you're using, right? Like if you're using a virtual machine in the cloud, yeah, you're going to be paying for whatever runtime and resources it uses. But say you're using some kind of serverless architecture for your application, if you're not getting any traffic, your code isn't running and you're not being billed for it. At least that's how the vast majority of cloud providers operate when it comes to serverless. So that's why they kind of make the argument that it's more cost effective to go with the cloud. Now, of course, you do have to take that with a little pinch of salt, because of course they're trying to, increase their customer base and make more money, obviously, and continue to grow. So of course they're going to say that their way of doing things is the best. But like I said, there is definitely a tipping point where it potentially becomes more cost effective, maybe to host things internally, especially if you're just focusing on playing around with stuff. Because if you're trying to like run a business in the cloud, that's one thing. And it can be very cost effective to do that compared to, managing your own infrastructure, your own data centers, all that jazz. But if you're just focusing on learning kind of like the core principles of cloud computing, like databases, virtual machines, containers, that kind of stuff, then having like, a home lab, assuming you already have something you can run it on, it's probably a lot cheaper to do it all yourself. Plus, you don't necessarily have to worry about like, well, I guess the one thing is if you host it all yourself, you don't have to worry about did I spin up too many virtual machines and it's going to cost me extra. Like if you house all the infrastructure yourself, you can spin up as many as you want, and it's, I mean, maybe it'll increase your power bill by maybe like a buck or two, but it's not gonna, significantly affect your bill at the end of the month. I guess unless you're doing insanely CPU intensive tasks, in which case, depending on what hardware you're running, then I guess maybe that could increase the cost. But again, point being is if you're trying to at scale do things in the cloud, yes, it can be more cost effective than housing your own infrastructure, housing your own data centers. But if you're just trying to focus on getting a learning experience, potentially not, which is, like I said, why there's that kind of like tipping point. The next thing, which we've also kind of sort of touched on throughout going through these, is reliability. Now, the cloud providers basically offer, they don't say 100% uptime because, you know, freaks of nature happen. But their uptime is, like I said, going to be significantly higher, and their services are going to be a lot more reliable than, John Doe's home lab that he's running out of his basement, right? So now, some home labbers do go to quite the extensive lengths to make sure that their home labs stay up and active as much as possible. And there are people that definitely try to shoot for that massive, like 99.999% uptime. I'm personally not one of those people. Um, Typically, I'll let my services run like as long as they can, but again, I think part of it also has to do is I'm the only user of my services. So if I want to take something down for maintenance or do reboots or something like that, I'm not going to have someone whining and complaining in my ear that the internet's gone down. In which case, if I did have that, then maybe my approach to maintenance windows and whatnot might be a little bit different. Um, but yeah, for me, it's not necessarily much of an issue. But if you are focused, on kind of running a business or something, yeah, you kind of want, that massive uptime because especially if you're like an e-commerce site, and you make, I don't know, if you, depending on how much money you make, any second or minute of downtime could be, thousands, hundreds of thousands, millions of dollars in lost revenue, which could seriously impact your bottom line. So having that reliability of the cloud is definitely something that is very appealing to going to a cloud provider because, like I said, when we were talking about, if you have customers in, say, different countries and whatnot, basically flipping the bill to ensure you have data center coverage in, those regions is not a cheap endeavor by any means. So basically the ability for you to, go into your cloud provider of choice and spin up a new instance of your service in a different region and be up and running in a matter of minutes compared to potentially the weeks, months, or depending on if you're building a data center, years to get yourself into a new region is tremendously and is a tremendous improvement compared to the alternative. And again, that uptime as well, because if you are a business and you're managing your own data centers and whatnot, if something were to happen to your data center, or maybe you're co-locating in a data center and one of your servers dies in that data center, that region could potentially be completely offline. Now, I would assume if you do have this, regional expanse and regional, access and whatnot, I would assume you'd have some sort of load balancing content delivery network or something. So in the event that a server goes offline or whatever, you can redirect traffic to somewhere else. So you wouldn't necessarily have, I guess, quote unquote, downtime, if you will. But latency would definitely increase if, someone from, say, the UK is trying to access your service, but your UK server is down, and now they have to go access, a server out in like Los Angeles or something. Is it going to be super noticeable to them? Probably not, unless they're really looking for it. But there is a definitely a difference there. So having that reliability of a cloud provider is definitely a big benefit. Now, we've kind of mixed in how home labs can kind of counteract this, but to focus specifically on home labs, one thing we kind of touched on is they do give you that hands-on experience. Now, cloud providers, especially if you're just trying to learn and experiment with stuff, isn't necessarily super cost effective, unless you don't have any infrastructure that you can play with at all. Because obviously, if you have to, spend the upfront cost of, spending a couple $100 on some hardware in order to spin up a home lab, yeah, a couple $100 might get you a few months of playing around in the cloud. I guess depending on how frugal you are, or maybe that'll be gone in a day or a week. Um, but the point still stands that, having, access, to all of the services at your fingertips, and being able to spin up and create things at a whim, and not necessarily having to worry about, the bill at the end of the month, is something that is very, very beneficial. And it's the other benefit too is like we touched on, there's a lot of, like, whether it's open source or other alternatives for resources that exist in the cloud that you can make use of in a home lab environment. Like, for instance, maybe you don't have access to S3 buckets, but you have like a network attached storage or something that you can network your application to, kind of for that archival type storage. Maybe you're not using like a DynamoDB table, but you have a MySQL database somewhere else that you're connecting to and communicating as part of your application. Maybe you're not using, whatever the cloud provider's container registry thing of choice is, but you're using, Docker containers to manage your deployments that way. Maybe you're not spinning up virtual machines in the cloud, but you're running Proxmox on one of your servers, and you're spinning up virtual machines in there and kind of getting that hands-on experience. So there's a lot of, one-to-one correlations between cloud offerings versus what you can get your hands on and play with in a home lab, and is something that employers are definitely looking out for. Now, obviously, if you have on your resume Azure experience or AWS experience, that's going to stand out. But if you come to the table, showing and demonstrating knowledge of understanding how these concepts and how these technologies work, that's still going to be a net benefit in your favor. And then that it kind of like goes into the next point of, like, practical skills, because the one there's a couple nice things about home labbing. One, it gives you, the skills to kind of like understand how these underlying technologies work, but at the same time, a lot of the fun about the home lab is just kind of like configuring and experimenting and playing around with stuff and kind of building your own infrastructure to make your life easier or automate things or whatever you're using your home lab for. And because, essentially businesses operate in the same way when they're using cloud services, there's a pretty close, correlation there between, stuff you would do in your home lab to spin something up versus what someone would do in the cloud. Like, one thing that's very common for especially like software development heavy organizations is to have their own internal Git server, whether that's hosted in the cloud or wherever, whether they're using the Atlassian suite, GitLab, Git, or some other Git solution. You having that experience of, hey, I have my own internal Git server that I host and I spun up in, my home lab, that's gonna, resonate with those employers that do have, the similar setups in their infrastructure. Um, and we already kind of touched on this too, the familiarity with cloud services in general, because while maybe you're not using, the AWS lingo of the services, or maybe you're not using the Azure or Google Cloud Platform lingo of, what virtual machines are, or what databases are, or what have you, having the underlying experience and knowledge of how they work, which you can absolutely do in a home lab, will for sure translate. Because at the end of the day, knowing like the specifics, nitty gritties of the tools, it's a lot like a programming language. If you know how databases work, it's mainly just a point of syntax. If you know how virtual machines work and how they operate, it's, again, it's basically like lingo and syntax and whatnot. And it's the same thing with like programming languages too. I kind of touched on that, because once you understand how to program and how the logic works of how to implement things, it's very trivial to go from one language to the other. Because if you already know the concepts of like how for loops work, how, sorting algorithms work, how, data structures work, all this stuff, it's very easy to say, okay, I want to use, say, a linked list data structure, and I want to iterate over it to find the nth element, and then basically remove it, and then whatever. It's really, if you know that that's what you want to do, it's really easy to look up how to do that in any programming language you want. The trick is having the knowledge to know that's what the solution is, which is where the experience comes from. So if you think of it that way, the home lab, having a home lab is essentially just learning a programming language. You're getting all of the core concepts. It's just then it's a matter of learning the syntax for the specific cloud platform that you're going to be tasked with using. Because it's a similar thing too if you go from like one company to another. If you've used CI/CD pipelines before, that's really what companies are looking for. Now, sure, if they're using Jenkins, they're going to prefer you to already have that background in Jenkins. But if you have the CI/CD background knowledge already, it'll be pretty easy for you to kind of get accustomed to Jenkins and learn, the Jenkins process and come up to speed. And it's the same thing with programming languages too. Of course, they're going to prefer someone that already knows the programming language they're looking for, whether that's Java, JavaScript, Python, or whatever. But if you have the programming background, learning a new programming language and coming up to speed isn't like an inconsequential task to overcome. It's not like you're starting from scratch. And it's the same thing with the cloud and home labbing. Um, so when it comes to like where to get started with home labbing, I mean, we've talked about this quite a bit. We could go on for another probably 2 hours and still not be done with it. We could, talk about it next week and the week after and the following week and basically every episode till the end of time, because how many iterations and permutations there are for how to configure a home lab and get experience with it. Because the TLDR is my home lab is different from your home lab, and your home lab is different from Bob's home lab, and Bob's home lab is different from Alice's home lab, because everyone has different wants, everyone has different needs, everyone wants to learn different things, and that is absolutely okay. The point of it is that you learn what you're interested in. Because my personal recommendation when it comes to learning how to program or getting into home labbing is don't follow guides and tutorials for the sake of following guides and tutorials, because you're going to quickly get bored and burnt out if you're not actually invested and interested in learning what the tutorial or the guide is telling you about. And I think this, at least for me, this comes back to my experience with formal education, which, if you've listened to the podcast for long enough, you know I am not a fan of. And the main reason for that is the whole idea of you being forced to learn something rather than having your natural curiosity inspire you to find out the answers to things and learn on your own. Because for me, I will go through quite the bit of pain and suffering in order to figure out how something works and get it working, whether that's in a programming language or in my home lab, specifically because I want to learn how it works and I want to get this service or I want to get this feature implemented. It's because it's something I want to do, and it gives me that drive to push through, the low points and the annoyances and the all the dead ends that you run into throughout the learning process. And that's what's really going to help you kind of learn stuff, because if it's something you're interested in, if it's something you're passionate about, it's going to be a lot easier for you to overcome those hurdles when they come, because they will come. Whether like specifically in a home lab, there have been so many instances where I've run into a roadblock of some kind, more or less because of my own doing. Only then I realized later that, oh, I didn't follow this one step, and I've now been beating my head against the wall for 2 hours, or whatever the case is. So yeah, the thing is though, if you're not all that interested in the service or the system you're setting up and you're just following a tutorial, if you get stuck, there's a lot higher likelihood that you're probably just going to be like, I'll just give up on this one and I'll go to the next tutorial. But if you're actually invested in it and you want to get it working, you're going to be a lot more likely to stick it out and push through and figure out, what the root cause of your issue is, and get it figured out. So I guess to give you a practical example, Don't set up a guacamole server with an SQL backend just because a tutorial showed you how to do it. Now, if you want to set up a guacamole instance with an SQL backend, absolutely go do that. But if you don't necessarily want to, don't follow the tutorial to do it, because you're not going to be invested in it, and you're not going to be as fulfilled when you actually get it working and you can have that resource, on your network. Now, maybe for instance you want to do monitoring of your home lab or whatnot, and you're trying to look up, how can I set up dashboards and monitoring, and that would be a fantastic way to look up tutorials and guides on how to set up whatever your dashboard solution is that you settle on. I think at least what I use is Grafana. I think a lot of home labbers tend to gravitate towards that, but you don't have to. You can use something completely different, and that's okay. The point is to find something that you're passionate about, and use those as your tutorials to get into home labbing and learn how these technologies work. So, like we kind of touched on the benefits there, um, they're basically kind of endless. The more experience you have, managing the infrastructure, managing the services, using the services in general. Is a huge benefit, especially if you. One thing I guess you could also do is if you're curious for ideas of what to run in your home lab to get experience, is you could look at just browse job applications for a field you're interested in, whether that's like a DevOps type role, a software engineering type role, and see what technologies and services they're looking for you to have experience in. And then if any of those pique your interest, you do some research on them. Maybe you spin those up in your home lab and incorporate them in your infrastructure. One thing we talked about when we were talking about SemGrep was SonarQube. SonarQube is pretty widely used in the enterprise as part of like CI/CD pipelines for like code auditing and whatnot, for like static analysis. Maybe you aren't stubborn like me and you're willing to pay the license fee, or maybe your programming language doesn't need the premium license fee or whatever in order for it to actually work. In which case, you can spend that up and get hands-on experience using one of those technologies that these enterprises that you're looking to get a job at also utilize. So that's another way where you can kind of get inspiration for ideas, and basically just having that on your resume is very beneficial to employers, because one thing that I think people tend to often overlook is they'll see a say like a job posting, and they'll see it asks for experience in these types of technologies, but they don't have any of those experiences in their current job or whatever, so they think they're not qualified and they don't apply for it. But the fact of the matter is, they use some of those technologies in their home lab, but they don't, point that out at all. So I would encourage you to, whether you explicitly call it out or not. I mean, there's different ways that you can phrase it and word it, but call out those experiences that you have using your home lab, on your resumes, because honestly, when it comes to my experience looking for jobs, the various personal projects and home labbing experience that I have, at least in my opinion, has played a significant role in me getting the various jobs that I have over the course of my experience working as a professional software developer. Because if I only was able to take credit for things I did in a strictly professional setting, I probably wouldn't be where I am today. I'll just say that much. Um, but the other benefits of doing a home lab versus, specifically cloud computing, kind of going back to the cost part. I know we've talked about that quite a bit already on the podcast this week, but if you already have the infrastructure at your disposal, say you're already running a home lab, say you already have Proxmox installed on a hypervisor, on a server somewhere, it's going to be a lot cheaper for you to just play around with, virtual machines, Docker containers, databases, all that stuff. It's going to be a lot cheaper for you to play around with it on your own infrastructure than doing it in the cloud. And also, kind of in a similar vein, while we said that flexibility was a benefit for cloud computing, if you already have the infrastructure at your disposal in your home lab, it's kind of easier to do it that way because uh, you can go at your own pace. You don't have to worry about you spun up a virtual machine and now it's just kind of sitting idly in the cloud, costing you money even though you're not actively doing anything with it right now because, life happens, you got busy, so you don't necessarily have to worry about essentially wasting you money that way. So having that kind of, flexibility with having the actual stuff in your home lab is definitely a plus. So I think that's kind of about all I wanted to talk about with cloud computing and home labbing. Basically, I guess the TLDR here is you can get some very comparable experience spinning up things and playing around with stuff in your home lab that will maybe not one for one translate to the cloud, but will definitely give you the requisite background and knowledge that will translate to the cloud, which will make it a lot easier for you to come up to speed on the various cloud technologies compared to if you never had any of that home labbing experience. But before we go, let us return to our trivia question for the week. So, this week's trivia question again is, what was the name of the computer controlled radiation therapy machine produced by Atomic Energy of Canada Limited in 1982? That was involved in at least 6 incidences between 1985 and 1987, in which some patients were given massive overdoses of radiation due to concurrent programming errors, also known as race conditions. If you said the Therac 25, congratulations, you got this week's trivia question correct. And this one is I guess as morbid as it is, it's one of the examples that if you've been through any kind of software like development classes, when you get to like the multi-threading kind of stage and learning about race conditions, this is a story that you're almost certainly going to hear about because of how prevalent it is. And this is just kind of going back to why it's important to make sure that you make sure your code is free of any kind of race conditions. And also why race conditions can be so hard to track down and debug, because if you've ever tried to debug a program with a race condition, it is one of the hardest bugs to track down for a number of reasons. One of them being sometimes everything works fine, sometimes things don't work at all. Other times you'll get one output and other times you'll get something completely different. So your results are basically never consistent. But I guess the silver lining to that is if you're experiencing intermittent bugs and they're always happening like in kind of the same area, sometimes it works, sometimes it doesn't, and sometimes you get variable results. There's a decent chance that could kind of elude you to the fact that maybe this is a race condition, and potentially kind of lead you down that path of actually getting it solved. So yeah, I thought that was a good, interesting trivia question for this week. But if you enjoyed this episode, definitely be sure to leave it a rating and review and subscribe to the Dark Assassins podcast if you haven't done so already. And be sure to share it around to any friends or family members you have, because as I've mentioned in previous episodes, the growth of this podcast is all thanks to you guys. So keep up the good work sharing it around. And if you have any questions about this week's episode or have any comments or ideas or topics for future episodes, you can shoot me an email at contact@darkassassinsinc.com, or if you're on YouTube, you can just leave a comment down below. And that's going to do it for me in this episode of the Dark Assassins podcast. Until next time, my fellow assassins, remember, bool nothing equals true. If action not equal to null, return true. I'll see you next time on the Dark Assassins podcast.